explain me this calculus? Well, it's not so difficult. Try it.
يقول لك I will help you. خليه افتح من هسه خليها
From ladies. Yes, please. Thank you. Yes. So please come here and respond.
I think that is related. I think that is related to the areas. Some areas have water chlorine. This water chlorine increase the level of carry, and the area don't have water chlorine that decrease. Sorry, and they don't have water chlorine that increase the level of carry.
Thank you. You notice that the explanation was not so difficult. The horizontal axis shows the mean average of the fluoride in the water, and the vertical axis shows the average number of decayed mist and filtered. Decayed
mist and film.
mist and
Filter.
DNF. And each point shows a province, or as this study has been conducted in the United States, each dot shows an state, or a state in the United States. For each point, you can draw a vertical axis, vertical line to the horizontal axis, shows that what is the average of fluoride in this state? Something between 1.5 to 2 parts per million, or ppm. And what is the average number of DMF in permanent tip? 200.
300
300 per 100. 300 per 100 equals 3. In 100 students, we have 300 decayed mist and film. It means that on average, each student in this state, on average, each student has 3 decayed mist or film. What about this state? The level of fluoride in less than 0.5 ppm. And the average number of decayed mist and filtered is something between
60
to 8. Maybe about or around 7. This graph shows that by increasing the concentration of fluoride in water, the average number of decayed mist and filtered will decrease. And you can see that up to a certain concentration of fluoride, the number of decay and mist and feed or DMF will decrease, and this is something between 0.5 and 1 ppm. And after 1 ppm, although the decline of the number of DMF continues, but the decrease is not so prominent. So it shows that the point between less than 1 and more than 1 is very important for prevention of dental caries. If the concentration is greater than 1, the number of DMF, average DMF is very low, and if the concentration is less than 1 ppm, the average DMF is relatively high. This is called an observational study. Observational means that the researchers just observe the situation. The researchers just measured the concentration of fluoride in water, and they just asked the people about the number of teeth that has any problems. This is observational. After this observational study, the researchers were interested whether by adding fluoride to the water of provinces with low level of fluoride, they can improve the dental health or not. So in this study, they selected two groups of provinces. Both states in both groups had low levels of fluoride. The lifestyle should be the same. The average number of DMF also was similar between two groups. Just in the right side, they added some fluoride to water, and the left side left alone, without any intervention. This is an example of interventional studies. Interventional study means that we intervene. We did manipulate the population. What was the manipulation? Adding fluoride to water. So after an observational study, they conducted an interventional study and noticed that in all of these 4 age groups, adding fluoride caused reduction in DMF. For example, in 6 to 9 years old group without fluoride had 2 decade death, and in the group with fluoridation, it was less than 1. And in the oldest age group, 15 to 16 years old, the group without fluoride had on average 16 decade teeth. But after adding the intervention group means the groups that had received fluoride, the number of decayed teeth was about 10 on average. So we can say that adding fluoride is responsible for reduction of about 6 or 7 decayed teeth in this age group. In younger age groups, effect is less because they had less time for fluoride to effect. The fluoride had less time to exert its effect on the teeth health. This is called an interventional study because we did manipulate it. And the researchers and the health authorities decided to fortify water with fluoride. Fortify means adding something to something else. For example, we make fortify fluor with iron. It means that we add some iron to fluor, some iron to bread. And this is an example of fortification of water with fluoride. A few years later, some people who were against intervention. You know that many people are against vaccination. In your country, also in my country, even in Western countries, in the United States, there are large numbers of anti-vaccine people. People who believe that vaccines are harmful rather than useful. And there are also a huge number of people who are anti-chemical interventions. They have some concerns that adding fluoride may not be useful. It also may have some harmful effects. For kidney, one of my students showed that adding fluoride can increase blood pressure, and also adding fluoride can increase some problems in the dental tissues and also in bone. Okay, but they were, they had some concerns about cancers. They said that we do not know what will be the long-term effects of fluoride. So they decided to discontinue adding fluoride to the water. And you see that after discontinuation of fluoridation in some states, the number of DMF again rose. So we have three pieces of information. First, an observational study shows that states with higher level of fluoridation had a lower level of dental caries. The second piece of information was an interventional study that showed by adding fluoride we can decrease the number of dental caries. And the third part of information came from discontinuation of fluoridation and showed that by discontinuation the number of dental caries returned to its previous number. We will talk about observational and interventional studies in later sessions. We just introduced you some brief examples of the observational and interventional studies. It's a very good example that shows how an intervention may be useful. First by observing a phenomenon, then by intervention, by manipulating, and then by removing the manipulation, the situation returned to its previous stage. But there is a question that rose in, in the population about, is fluoride useful or harmful? What is the situation? It's related to the person, and also it's related to another important thing. Is it useful or harmful to, ingesting fluoride?
No, it's a harmful one.
It's harmful.
For a long time.
The body cannot excrete fluoride, so it is harmful. But we just showed that, just noticed that fluoride ingestion was useful for dental health.
It's for dental, only for the oral cavity, not drinking.
Also, after we brush our teeth for twice a day and lose the teeth that's contain fluoride. So there's no need to put fluoride in water.
Thank you. Your friend says that if we use some toothpaste with fluoride, we do not need to ingest extra fluoride. Yes, I agree with you, but there is again a question. The question remains. Let's talk about another element. Iron is a poison or is a medication? Which one is correct? Yes, it depends on
the situation of the patient or the situation of the
situation of patient, and also it depends on another important factor.
Type of the iron. Type of the iron.
Type of the iron, yes, but
How we can use it?
for every chemical, it depends on the dose. If the dose of iron is low, it's harmful because we can get anemia. If the dose of iron is very high, it is again harmful because it can cause hemochromatosis. What about about Cu? What about blood glucose? Higher blood glucose is good or lower blood
It
glucose?
depends on our body needs.
It depends on the range of blood glucose. If the range of blood glucose, if the concentration is low, it will be harmful for our body. It can produce faint.
Yes.
If the average or if the normal concentration of blood glucose in a patient, in a person is very high, it also will be harmful. What about blood pressure? Higher blood pressure is harmful or lower blood pressure?
Both of them.
Both of them, because we know that low blood pressure can be lethal, because with low blood pressure, the blood supply cannot reach to our brain, to our kidneys, to our heart, even to any organs of the body. So the relation between those and effects for many chemicals is something like that. In this range, it has the highest, it has the lowest side effects. For example, if iron intake is something between this level and this level, we had the lowest side effects of iron. If iron is lower than this level, the problem of iron deficiency anemia will be increased. And if the iron is higher than this level, then the problem of iron accumulation. And for example, chromatosis may increase. So the dose shows the toxicity. So aspirin is a medication or is a toxin? It depends on the dose. In high dose, it can be a toxin. In low dose, it can prevent heart attack. Each medication can be a medicine, and also at the same time, this medication can be a toxin. For the fluoride, at that time, the majority of population were fluoride deficient. So it was necessary at that time to add fluoride to water. But now in this age, we know that the fluoride is present in many seafoods. The fluoride is present in many toothpaste. The fluoride can be found in many supplements. So nowadays, many countries are against adding fluoride to water because now we have sufficient amount of fluoride in many parts of the world. So if I ask you, adding fluoride to water is harmful or is useful, the answer is that it depends on the concentration of the fluoride in our intake. Not only in water, but also in foods. It may be the case that the concentration of fluoride is very low in water, but we receive a large amount of fluoride by ingesting foods. So it depends on the amount of fluoride that we receive. In my country, for treating iron deficiency anemia, one strategy was to adding iron to bread. But after a few years, we noticed that many people take many supplements, and in these supplements they receive required amount of iron. So adding extra iron to bread may be harmful because many people used to use supplements. Unfortunately, using supplements is more than the required amount in developed countries and also in developing countries. You may buy milk and you can read that this milk is fortified by iron. You may buy yogurt and you can see that this yogurt is fortified by some probiotics and some vitamins and some minerals. You may take you go to the doctor and doctor prescribes you some medications and some supplements that also again provide you some medication. So the right answer for the question, what is the nature of this medication? Is it a toxin or is it a medicine? Is that it depends on the dose. It depends on the amount of this chemical in our diet, in our air, in our environment. If the level is higher than required, it can be regarded as a toxin. If it is less than the required one, it can be regarded as a medicine. Let's go to the next example. First, briefing the situation. First, the natural level of fluoride in drinking water showed that the dental caries has a reverse correlation with fluoride. Reverse means that by increasing the amount of fluoride, the number of dental caries decreased. This is called a reverse relationship. The first one, a trial or an interventional study, was conducted and tested the hypothesis that is dental caries related to fluoridation of water, and the answer was that yes, fluoridation of the water can decrease the number of dental caries. And in the third phase, the fluoride was removed from the water that used to be supplemented by fluoride, earlier years. By removing the fluoride, they noticed that the EMF against increased and rose to its previous level. Who is it?
John Snow.
John Snow. John Snow was a physician. He was not an epidemiologist. He was an anesthesiologist. His specialty was anesthesiology. But he was interested in conducting epidemiological studies too. And nowadays we know John Snow as the father of the modern epidemiology. Please, if there is any question, please ask me. If there is no questions, please do not touch each other. I'm here to answer your questions. I'm here to listen to your comments, but please do not touch each other. If there is an important issue, please go out and talk to your friends. Please, in the classroom, if you are talking with your friend, you are interrupting the whole students. And you are also interrupting me. So if you have an important issue, don't worry, you can go out and after solving your problem, return to the class. Thank you. Nowadays we know John Snow as the father of modern epidemiology because he introduced us the epidemiological studies with suitable control group. Suitable control group. Without control group, we can conduct observational studies. We can, excuse me, I correct myself. Without control group, we can conduct descriptive studies. In descriptive studies, we describe the population by terms of who, where, and when, if you remember from yesterday. For example, if I'm interested in the description of cholera disease in London, John Snow was interested in that issue, I have to explain and I have to measure and to show you the number of people. Then I have to describe their age distribution, their gender distribution, their job, their geographical locations. All of these information are classified as descriptive. But for analytical, what is the analytical objective of such a study? What's the question?
Determine the risk factors
What is the risk factor or what is the causes of getting cholera?
Contaminated
The
water.
bacteria is the cause, but at that time they were not aware
It
of
was the contaminated water.
contaminated water. You know that contaminated water is responsible,
Yes.
but at that time
They thought
there
it
were
was
two hypotheses.
air.
The William Farr believed that there is something harmful in the air. William Farr was in charge of health authority. You can say that he was, for example, Minister of Health of that country. Okay? So William Farr believed that there is some cloud in the air that was called miasma. He believed that miasma is a very thick cloud of unknown nature, and it's very heavy. Due to its heaviness, it tends to locate in lower altitude. And London had some higher elevation and some lower elevations. Suppose that this is the map of London. If this can be supposed of the map of London, it's Thames River. The sea. Which part of the city has a higher elevation from sea level? The left side or the right side?
Right side.
Higher elevation. Left side has a higher elevations because we know that sea level has the lowest elevation of residence in the world. We do not have any locations that are lower than the sea levels, okay? So this is lower level. William Farr had noticed that the number of people who died due to cholera are concentrated in the lower elevations. So he believed that there is something harmful in the lower elevations. And he believed that this is the miasma, as I mentioned earlier. Miasma was believed to
Bad
an
air.
unknown situation in the air, a bad air. And William Farr also conducted a study, and that study at that time was not a bad study. He provided a table and showed that by increasing elevation from sea level, the number of people who died due to cholera will decrease in each 10,000 population. For example, in this table you can see that for people who live in less than 6 meters, 20 feet equals about 6 meters. The people who live in around the sea level, less than 6 meters from the sea level, in 8,000 population of this group of people, the number of people who died due to cholera is around 100 people. By increasing elevation, the number of people who died due to cholera decreased. For example, in the highest level of city, the number had decreased from 100 to 8 out of 10,000 people. So this observation confirmed or was in favor of his theory. The theory was that if we increase the elevation, the number of people who die will decrease. But John Snow believed that there is something bad in the water. Okay. There were some companies that provided water for the homes from the Thames River. And all big companies were located at the lower elevation of the city. The Lambeth, South Park, and any other companies. So the companies provided water from lower levels of city, the lower levels of the London, and provided this water to the whole city of London. The Lambeth company have moved from this location to a newer location that was located in a higher elevation of the city. Snow selected. What did the snow do at that time? The snow selected a sample of households. Actually, all of these households were located in the lower elevation. So, we believe that the level of miasma is the same in this household, okay? Because all houses were located in the lower elevations. But some of them used to receive their water from South Park Company, and some another homes had received their water from Lambeth Company. And Lambeth Company have moved from the old location in the lower parts of the city to higher location. At that time, they did not believe that water is polluted. And for example, the reason may be that the Lambeth had rented this location, and after termination of the rent, the managers moved to another location that was cheaper. The higher elevation was cheaper. So the location or the source of water has changed for Lambeth. After this study, Snow showed that Snow also provided this table and showed that by moving Lambeth Company from this polluted location of the city to the new location that were, at a higher level from sea level, he conducted a shoe leather epidemiology. Shoe leather means that you have to put a shoe, a leather shoe, and go from one home to another home to another home. The field epidemiology. Field epidemiology means that you should go to the field. Is it any problem? You have a question? Why not? It's just for you to talk during the class. I've asked you, and I will ask you again. If there is an important issue for you, please go out and talk. I do not prohibit you from going out. Each time you want to go out, feel free to go. But when you are in the class, it is very beginning, the rule of the class. Please be quiet and listen. Sometimes I ask you to talk, and at that time I will be quiet. If both of us are talking, we're interrupting each other. Okay? So please have concentration to the issue of the class. By shoe leather epidemiology, Snow believed that we should go to the field, we should go to every house and ask some questions. He just asked two simple questions. The first question, what is the company that you receive your water from? Is it Lambeth or Southport? The second question, have you ever had any case of cholera in previous, for example, 6 months or not? So 2 questions. One question about the disease, that is cholera, and another question about the risk factor, that is the water source. And after analyzing, he classified the companies as Salzburg and Vauxhall and other companies. S stands for Salzburg and B stands for Vauxhall in my explanations. And Lambeth companies and other districts that were not so important because the big companies was 3 at that time: Salzburg, Vauxhall, and Lambeth. There were about 40,000 houses that used Salzburg and Vauxhall company, and about 26,000 houses that used the Lambeth company. And there were 1,263 deaths from cholera in this group of patients and 98 deaths in that group. Can we compare these two figures or not? Can we compare 1,263 versus 98 or not? Is it okay to compare these two figures? Can I say that the number of deaths in this group is lower than this group?
Because the number of the house is different.
Thank you very much. Please clap. This is good absolute number. Absolute numbers are not useful. We need relative numbers. The relative number produces by dividing the number of who had event by total number in that group. So if we divide 1,263 by 40,000, we reach this number. And we can compare this number with this number because it says that 315 people died due to cholera out of 10,000 population in the first group. And 38 people have died of cholera in the second group, again in 10,000. By dividing this figure by this figure, we reach a number that is not related to the total population. Because in the last column, the number, the denominator is the same. So we cannot compare this number with this, but we can compare this number with this. In the last column, the difference of the total population is removed, and we call this figure a relative number. We will discuss about these indices in later sessions, but just now remember that 315 out of 10,000 is about 8 times of 38 out of 10,000. So people who receive water from Salzburg and Vauxhall had about 8 times higher risk of die due to cholera. And Snow showed that although the exposure to air, the exposure to miasma was the same because all the houses were located in the lower elevations. So John Snow showed that William Farr that if your hypothesis was true, we expected that the number of deaths were the same for these two populations because both of the groups were located in lower elevations. And you believe that the lower elevation, the miasma, is responsible for cholera disease. But I show you that even in the lower elevations of the city, the number of deaths is related to the company. And the company shows the location of the Thames River that the water was extracted from. Lambeth company get water from less polluted area because at that time there were not wastewater treatment and wastewater was released into the river. Such a case in some rural areas in our countries. In rural areas we do not have any wastewater facilities. So the waste is released into the river, is released to the environment. This is a good example of a an analytical epidemiological study because it analyzes the relation between sources of the water and cholera and the exposure to miasma and cholera. We had two hypotheses. Is the cholera related to miasma? The answer after this study was no, because both groups had the same exposure to miasma, but the number of deaths was different. Second question, is cholera related to water source or not? The answer was yes, it was related. If you remember, yesterday we just talked about that. If we tell you the value of X and your estimation of the value of Y improves, we can say that there is a relation between X and Y. If I tell you that I will take my water from this company, you can think that the risk of getting cholera or the risk of dying due to cholera is higher than average. And if I receive my water from this company, the risk of dying from cholera is lower than average. So there is a statistical relation between source of water and getting cholera or dying due to cholera. But they did not know what agent may be in the water. Now you know that there are some bacteria, for example, Vibrio cholera, that has a fecal-oral circulation. Fecal-oral means that it spreads from feces, from stool of the patients to the food or to water that are ingested through our mouth. It is called the fecal-oral circulation. But at that time, they were not aware of any microorganisms. It shows that even without knowing, without being familiar with the pathogenesis, exact pathogenesis of the disease, we can prevent disease. You know that John Estow was an anesthesiologist, and he anesthetized the Queen of England at that time. And his being familiar with Queen helped him to persuade Queen, to encourage Queen to please close these companies. And after closing these companies, the cholera epidemic was stopped. So even without knowing microorganisms, even without knowing anything about the exact cause of the disease, we can prevent disease by intervention. This is a good example. This is another example. As another example, we can talk about just by an observational study without any intervention. He conducted an observational study and confirmed the hypothesis that water is related to cholera. Then he intervened, he manipulated the population by closing the companies that he believed are polluted. The disease was controlled. Another example is streptococcal infection and rheumatic fever. Your knowledge is now much higher than the knowledge of physicians 200 years ago. You know that streptococcus is responsible for producing both pharyngitis and rheumatic fever. And you know that this is an autoimmune disease. You know also the mechanism of producing rheumatic fever. But at that time, at more than 100 years ago, the physicians observed that the risk or the chance of rheumatic fever in people with severe pharyngitis is much higher than people with less severe pharyngitis. The severe cases had almost 10 times higher risk of getting disease. 3. in 100 divided by 3 in 1000 equals 10 times. People with severe pharyngitis had a 10 times higher risk of getting rheumatic fever. And at that period of time, penicillin was discovered from the fungi, from penicillium fungi. By prescribing penicillium, they noticed that the risk of rheumatic fever had decreased dramatically. This is a second example that shows even without knowing the mechanism of disease, even without knowing the actual cause of the disease, we can prevent the rheumatic fever. And the last example is about smoking. Which agent is responsible for producing lung cancer in smoke? What is harmful in smoke? Nicotine is one of them.
Poison in tobacco.
Which poison? Nicotine is a poison. Which poison are existed in smoke? CO2, CO2 or CO, carbon monoxide and carbon dioxide, both of them are existed in the smoke, but they are not cancerogenic. They cannot produce cancer. They have some other harmful effects. Tobacco, which component of tobacco is responsible? We know that there are more than 5,000 chemicals in tobacco smoke. Okay? We do not know the exact cause of the cancer. It may be nicotine, it may be some unburned hydrocarbons. Unburned hydrocarbon means that hydrocarbons that are not completely oxidated. For example, polycyclic aromatic hydrocarbons. It may be some heavy metals. In producing tobacco, some heavy metals may be added to the cigarette. Also, some scientists believe that the heat stress, the thermal effect of smoke can produce some cancers in oral cavity, okay, as a physical agent. So we do not know which agent may be the exact cause of lung cancer. But we just noticed by removing the smoking, by stopping the smoking, or by not starting the smoking, by removing the smoke from our life, the risk of lung cancer is decreasing dramatically. It is a third example. Almost 60 years after finding that smoke is related to lung cancer, some scientists started to find the biological relationship between smoke and cancer. The exact biological mechanisms started to show the relation at least 60 years after observing that if the people are encouraged to discontinue the cigarette smoking, the risk of getting cancer will be much higher, or the cancer can be prevented. Do you have any questions about the prevention levels, about the descriptive and analytical studies, and about anything that we have just discussed in these 2 hours or so? Can I ask you some question? If you do not ask me, I will ask you some questions. What is the most important issue in analytical studies? What is the most important factor in analytical studies? We cannot do an analytical study without this.
Determinants?
No. want to do research and we want to do analytical. Analytical means that we want to know what is the risk factor for what? What is the cause of disease? What is the agents? You are not wrong, but my answer is another.
Doctor, 3W?
3W is crucial for descriptive studies. You are talking about descriptive study. In descriptive study, we should describe the disease in terms of personal characteristics, in terms of geographical location, and in terms of time variables. But in analytical study, when we are talking about the cause of a disease, we need a control group. So, what is the crucial component of an analytical study? The answer is a control group. Let me explain more. I want to know what are the risk factors of stomach cancer. If I select 100 cases of stomach cancer, and ask them about the smoking. Do you smoke? And 30% answer yes. So I want to know, is there any relation between smoking and stomach cancer? And I select a group of people with stomach cancer and ask them about their smoking. And the answer is that 30% of this population are smokers. So, is there any relation between smoking and stomach cancer? Why yes?
Because 30 people from these 100 people who have stomach cancers do the same habit. So there must be a relation.
Any other explanation? 30% of stomach cancer patients have history of smoking. The question is that, is there any relation between smoking and stomach cancer? My answer is no, we can't say. I disagree with you. Why? Why I disagree with you?
Because it's very small percentage, like some people have smoking but don't have this disease. So, but if we say that 50%, like we should consider it as a risk factor.
Your friend says that 30% is not enough, maybe 50% or 70%. But again, my answer is that no, we can't say. Yes?
Because we ask just the stomach cancer patient. You should ask the whole population.
Thank you very much. I just mentioned that we need a control group. We need a control group. It means that we have to ask another 100 healthy people. Healthy people means that they do not have cancer. If I select a group of people with the same age, with the same gender, with the same lifestyle, but the only difference is that they do not have stomach cancer, and 30% of this population also say that we have smoke. 30% says that we are smokers. What would be the conclusion? Is there any relationship between smoking and stomach cancer or not?
No.
Why not? Because we thought that if our knowledge about the value of X improves our estimation, improves our guess about the value of Y, we can say that there is a relation. in this example, the same percentage of cases and controls have exposure to smoking. So if I say that he used to smoke or he do not used to smoke, does it help you to have a better estimation of the chance of getting cancer? No. Just 10% of controls say that we are smokers, and 30% of stomach cancer say that we are smokers. Now, is there any relation between? Yes. Because by knowing the cancer situation, our estimation of the smoking prevalence will improve. We know that cancer patients, on average, 30% of them are smokers, and on average, 10% of healthy people. Healthy means that people, they may not be healthy at all. They are just free of stomach cancer. They may have, for example, some joint disorders. The control group should be free of that kind of disease, okay? So if 10% of this group of population are smokers, we can say that there is a relationship between smoking and stomach cancer. What about this?
No.
I asked a question from a stomach cancer patient, and I noticed that 30% of them are smokers, and in a control group, in a similar control group, I noticed just 50% of them are smokers. Is there any relation between smoking and yes or no?
No.
Yes, there is.
Why?
You should encourage them to smoke.
Because if I tell you that he or she has cancer, and I ask you, is it probable that he or she smokes more than 40% or less than 30%? In this example, you know that people with who had cancer has a 30% chance of smoke. People without cancer have a 50% chance of smoke. My question is that, what is the average prevalence of smoking? What is average? 30% and 50%. The average of these may be something about 40%. You say that something about 40% of people in this population smoke. And I tell you that he or she has stomach cancer. Does it help you to improve your estimation or not? If you know that he has cancer or she has cancer, you can say that the chance of smoking is less than 40%, because we know that cancer people have 30% of smoking. If I say you that she or he is healthy, does not have stomach cancer, you can say that the chance of smoking is higher than 40%. So there is a relation, but the relation in this situation is reverse relation. Reverse relation means that we expected that smoking increases the risk of cancer. But in this hypothetical example, we saw that smoking decreases the risk of cancer. So in both cases, 30% against 10%, there is a relation. 30% against 50%, again, there is a relation. But in the first example, the relation is direct relation. But in the second example, it is an inverse relation. Okay? So the most important thing is that we had a control group. Without any control group, you cannot say anything about the cause of the disease. Without control group, you cannot do analytical studies. So, if in the final exam I ask you, what is the most important factor in analytical studies?
Control
And
group.
answers maybe the sample size, or maybe the, for example, 3W, or maybe the time, or maybe the location. The answer is none of them. Just the
Control group.
Without control group, it is impossible. Without control group, it is impossible to talk about cause of the problem, cause of the disease. Okay, I think we can have a 15 minutes rest again. After 15 minutes.